by now you have run some regression models, and you've probably compared the results one against the other to see which was your best model. You may have run multiple classification models and evaluated them against each other. What if you want to run a regression model and then use it for classification purposes, and this is done more frequently than you might think, and compare it to other classification models? Well, let's see how we might be able to do that. Here we have a regression for the bike buyers data set. Let me go ahead and run that, and we'll see what we have just as a reminder. So I've got a bunch of features that we've created indicator variables for a number of the categoricals. I can see my performance on the various metrics. My linear regression model is this. And then if I look at, let's see where I applied the model. Yeah, right here I applied the model to the population, and I can see the actual purchased bike value and my predicted purchased bike value. Now, how can we convert these two numbers into a confusion matrix? Let's go ahead and work our way through that. First, I'm going to go back to the design view, and we want this labeled data. I'm going to go ahead and delete the connection wire to the result wall, and I'm going to see if we can find a way to output this to my hard drive. So I'm going to bring in write Excel. So we're going to write an Excel file, and I'll take that labeled data and make that the input. And then the file will go to, I'll just put it on my hard drive in my downloads directory. And we will call it Bike Buyers Regression Results. Save it as an XLSX. I don't need any additional sheet names or anything like that, so I'll go ahead and just leave the other parameters at their defaults. And then if I want, I can connect the throughput to my results output wall, just so I have that. I'm going to change the number format, which I believe is basically a leading digit if it's there, and 1 decimal place. I'm going to change that to 3 decimal places. So 0.000. If I do a pound sign there, that means the number is optional if there's something in that decimal place or digit place. But the 0 just says, give me the number, and 3 decimal places no matter what. All right, so now I run this. And if I go to my file explorer, here are my regression results, my Excel file. And sure enough, I've got all that data available. I'm going to first convert this to a table. And it's hard for me to see the black on blue there, so I'm going to change this to a lighter color. Yeah, we'll make it yellow. All right, so I'm going to add a new column here that says prediction. So I've got my predicted value there, but my actual prediction is, did we buy or not buy? So I'm going to round that to 1 or 0. Okay, and at this point, I don't really need all those decimal places. So let's see, that's reduce. All right, there, that looks a little bit better. So here's my prediction. And now I can start, next I can say accuracy. And I'm going to copy this column So then I keep all that formatting. Okay, so now I can determine, was I accurate? Okay, well, if my prediction, so let's see. So my formula is going to go like this, equals if my prediction equals the actual purchase bike numeric, well then I'll give myself a +1 for accuracy. Otherwise, I'll give myself a 0. Okay. And looks like I will have to do my decimal place adjustment again. Okay. So now if I go down to the bottom, I can see I've got 66.6% accuracy in this particular model. Now I can even break this down further. So what are our, if I've got a binomial classification, I have a confusion matrix with 4 potential values in it. So here's what I'm going to do. I'll say true positive, false positive, false negative, and true negative. Okay. Now, so to calculate this, I'm going to use a combination of if and and. So the way I'll write it is equals if, and then I'll do my and prediction equals 1, and accurate equals 1. So if both of those are true, then I'm going to give myself a point, 1 point. Otherwise, I give myself a 0. All right. And you can see, okay, yeah, it looks like it's working correctly. Next, I'm going to do a false positive. So I'm going to copy this formula over. And that's one of the nice things about table calculations. I'm actually using the column names here, the column name headers here. So now I'm going to say if my prediction was positive, but my accuracy was 0. Now I give myself a point for a false positive or else a 0. Okay. All right. It looks like that one worked. Yeah. Okay. So far, so good. And you could probably guess what I'll do for the next two. I'm going to use this same exact approach. First time, I'll say if prediction equals 0, and I'm looking for a false negative, that means accurate would be 0. No, accurate would be 1. No, yeah, accurate would be 0. So false, I predicted negative, but it's falsely negative, so my accuracy is 0. Okay, so there is my calculation for that. And yeah, it looks like that. So 2 zeros equals a 1 here. And then finally, a true negative would be I predicted 0, but my accuracy is 1. So, and I could, of course, have done the exact same calculations using the prediction calculation or the prediction column instead of the accurate column. All right, so now I'm going to fix these columns as well. Now, if I go down to the bottom of any one column, I can see I've got 306 true positives, 159 false positives, 175 false negatives, and 360 true negatives. Now, just as a check, I've got 1,001. So I have 1,000 examples in this data set, which means that my combination or my sum of all true positives, false negatives, and true negatives should be 1,000. And yeah, it is. So I've got 4,000 cells there, but only 1,000 of them have a 1 in them. So my sum is 1,000. All right, so that looks good. And so from here, and of course I can also, in my table, decide, well, I'll just add my total row. And then down at the bottom, for those that I'm interested in, give myself those 4 sums. And then for accurate, I can do my average. And that doesn't do very well. I need that one presenting at more precision. So let's increase our decimals again for that one. So yeah, 0.666. All right, so we've got our components we need. We've got our accuracy calculation, and then we have our components we need for our confusion matrix. So from there, we can calculate all the other measures that we would have: precision, recall, F1 score, and so forth. All right, so that's how we can take a regression model and convert it into a classification analysis. Let's get back and see what we'd like to do next.